Will the future energy needs compatible with sustainability?
I think that today, if we wanted to meet our energy needs sustainably, it will be very, very, very difficult. In fact, I think at a price we will be willing to pay, probably impossible. So we need technological advances. On the other hand, I'm quite optimistic that those technological advances will happen because the energy scene is changing very, very rapidly. So I think we're on a good trajectory, but we haven't got there yet. And there are a lot of open issues still.
Mm-hmm. And what are the main challenges that we have to address?
I think there are some challenges which are not getting enough attention. And one of them is dealing with heat. If you go to a talk on energy, it's all about electricity. But if you look at the primary energy that we start with, coal we dig out of the ground, gas, hydropower, wind, etc. Something like 40% of that goes into electricity, so it's very important. And this, in principle, we know how to produce sustainably, although there's a very long way to go. Something like 20% goes into transport. So there again, in principle, we know how to make electric cars, so on. The problem is that the other 40% is being used for heat. It's being used to heat buildings, it's being used to heat water, it's being used as heat in industry. This is very, very difficult to replace. We can replace it with heat pumps, but then we put up the electricity demand by an enormous amount because the heat demand, at least in countries like the UK, it's very much concentrated in a few weeks in the year. So there are huge problems that are not being tackled with heat, domestic heat and actually also in commercial heat for water and space. And I think there are also problems with industry. Industry uses a great deal of heat. Some of it comes from electricity, but some is from burning fossil fuels. This is very high temperature heat. So we need to be thinking very seriously about how to change chemical processes so we can so we can manage heat without carbon. That's one of the really big challenges. Otherwise, I've forgotten what your question was. It was what are the challenges, I think. Was that right? Yes. Yeah, okay. So the other challenge, I think, is when we think about moving for electricity more and more to wind and solar. First of all, we have to remember that of the world's primary energy, wind and solar are producing something like 1.5%. So there's a very, very long way to go. That's the first problem. So it's a problem of scale. The second problem is that the generating cost, when we make electricity with wind, is becoming very cheap. It's as cheap as with gas. And solars are getting cheap too. That's fine when there are small amounts. But as the amounts grow, the cost of incorporating them in the system will grow and the cost will go up again. And it's also the case that the generating cost is not the same thing as the value. In some places, the wind blows at night. So in Texas, for example, there's an electricity company which is giving away electricity between 10 at night and 6 in the morning because lots of electricity doesn't know what to do with it. So the average cost of generating is irrelevant if you're giving half away from a commercial point of view. So there are big challenges.
Mm-hmm. And do you think the nuclear energy will disappear?
I think that nuclear energy has potentially a very important role to play. I'm personally not concerned about safety issues. I think they're serious, of course, but nuclear has a rather good safety record. The problem is that the big reactors that we've been building are looking very expensive, particularly in Europe. The French are going over budget with their reactor. My country has just bought one. Looks to be a commercial mistake. And one of the questions is if we move to much smaller reactors where we can standardize them and we can have economies of learning, that we build many, many more things that are just the same, we can bring the price down. I think this may be the future of nuclear, but it's difficult to get started because somebody's got to go out and build a lot of small reactors to find out if it's true that when we built the fourth, the fifth, the sixth, the seventh, they're much cheaper than the first, and it hasn't been done yet.